in my library that I gave you for the clock, like I said, we have these constants, and we have these two functions. One is just to enable the clock output, and the other one is to init the PLL. And in the PLL range, you're gonna enter one of these. So I came up with the most useful numbers that we can get. Of course, you could add more, but these are gonna be the ones that we're going to use the most. 64 megahertz is the maximum that we can go. 40 megahertz is the one that we're gonna use very often, as well as maybe 50. And why is that? Well, because when you do 40 megahertz, if you go 1 over, that means that each cycle is 25 nanoseconds. If you go 50 megahertz, 1 over, each cycle is 20 nanoseconds. Okay? So that works beautifully. But if for some reason you decide to use 32 megahertz, then you go 1 over, things start to get a bit ugly. So that is 31.25 nanoseconds, but it's still workable. Which one is the one that I found that, is it 60 maybe? 60 megahertz? Yeah, that one is very ugly because your cycle is a periodic number, so it's something that you probably don't want to, when it comes to timing applications, your time base is not going to be something accurate, right? So it's going to be tricky to do the calculations. So you probably want to pick a number where you do the 1 over, gives you a round number for the cycle. Okay? That being said, this enumeration contains values for the the L, the N, and the M. And those are the values that you need to use here to get the actual frequency. For example, if we look at these values that I gave you here, so the R is an 8, what else? The N is another 8, right? That's correct. And lastly, we're gonna explain what all this means. Don't worry. And the come on, the M.
1 minus 1.
Did I do the M already? The M. Sorry, let me put that there because I have a very hard time trying to transcribe these numbers. So the R is an 8. The N is a what?
8.
Where is the N? Oh, the N is an 8. Okay. And the M is a 1. Why is it not working? I think I made a mistake here. Oh, I deleted something. There we go. Oh, because he has to use the HSI, sorry. I had the HSC selected. Sorry, I should have done this. So again, let's go back. By default, our system is using this guy, the HSI. That's why it works at 60 megahertz. Now, when we select to use the PLL is going to use either the HSI or the HSE. The HSE is the one that I had selected before. That's why the numbers were not matching. Okay? So we are going to work with the same HSI for this part. So that means that the source that goes into the PLL is going to be the same 16 megahertz oscillator. And then according to these numbers is what we're going to get there. So if what I gave you in the function here, so what you're going to have to do, oh my goodness, how do I get rid of all these things? It's becoming really, okay. What you're going to have to do in this list here, you're going to have to complete these numbers. I'm giving you the first 3. I'm giving you the R as an 8. R as an 8. And N as an 8. N as an 8. And M as a 1. So the result of that gives me 60 megahertz, which is very silly. Yes, that's why I gave you this one. Because why would you choose the PLL to get the same 16 megahertz that you're getting by default?
So basically, we use the QMX to figure out what
The numbers.
Okay.
Yeah, because here's the thing. There are certain limitations in terms of what these numbers can be, and that can get really complicated. So I'd rather you guys exploring this with CubeMX and playing with these configurations. And whenever a configuration is not possible, for example, that one is going to give you 20 megahertz. See, 1, 10, and 8. And there might be more than one configuration to get the same 20 megahertz if you play with these numbers. But once you start going crazy and changing things around too much, you may get things that are not possible. Like for example, this combination is supposed to be giving you 80 megahertz, and it's in red because 80 megahertz is just not possible. 64 is the maximum. Okay? So you're gonna play with this, and you're gonna come up with all these numbers. Now, how does that make any sense? Well, we need to look at the lesson a little bit. Here's the thing. How do we use the PLL as a system clock? The PLL has this formula. It has an input frequency. Let me just move this over again here, the CubeMX. The input frequency, F input, that goes into the PLL is this guy here. Is the PLL source. It can be either the HSI or the HSE. We're going to focus mainly on the HSI. Okay, then later we're going to change to the HSE. So 16 megahertz. So this guy is going to be hard coded to 16 megahertz. Now, let's go back to the 20. What was the configuration for the 20?
1
That
to
one.
8.
So when this guy is 16 megahertz, the N is, who can tell me what the N is? 10, right? The M is 10, right?
Yes.
No, the N. So times 10. The X is the R. I'm going to explain what the X means in just a moment. But the X is the R, which is 8.
10.
And then the M goes here, which is 1. So this ends up being 160 million divided by 8, which is 20 million. That is the simple formula. Now, why is it saying that the X can be R, Q, or P? It's because with the PLL, we can actually get 3 sources of clock. But we're going to mainly focus for this course on just the one, which is this one here, which is the system clock. Because this other one here, see, the R is for the PLL R clock that is used for the system clock. The Q is for the PLL Q clock that is used for the USB and the random number generator. Things that we're not going to worry about in this course. The timers yet, but the timers are going to use the system clock. And the P is for the ADC and I2C, also material for the next course. So mainly we're going to be using system clock, which is why for practical purposes, our X is always going to be R. Is that clear?
Yes. Yeah.
Okay, so the formula will always be F input divided in not even that, because if we're focusing on the HSI, it's going to be HSI 16, which is 16 megahertz, times N divided by R, and here divided by M. So this is going to be our formula that we're going to be using. So basically this one here. Oh, this thing is inverted, that's why it's like that. Now, there are some limitations here for the ranges. See, for example, this calculation that we do here, f input divided by m multiplied by n, has to be within this range for range 1 and within maximum this for range 2, and it has a bunch of conditions that are very hard to understand, which is why I rather you guys come in here and playing with this number, and then CubeMX is already going to handle those limitations for you. So whenever you're trying a combination that doesn't work, it's going to show in red. Okay? Any questions up to this point? So your task now is going to be first completing these numbers. The R, see the order here is not the best actually. Is R, yeah, so it's kind of mixed up. But basically you're completing the R, the N, and the M to get the values that you want here. Now, where are these things in the register? So if we go to the RCC PLL configuration register, which is this one, see, it talks about this formula again, and this is where the N, the R, and the M are. As you can see, the R, the value 0 is reserved. It can never be 0, which is why whatever you write is subtracted 1. Then the PLLM should be somewhere in here as well. It's at the very, oh, the M and the R are, the N are here. So the M, the 0 means 1. Which is why, when we want to have a factor of 1 on the M, whatever we enter here gets subtracted 1, so it actually can be 0. That one will be as 1. So I'm trying to explain why this minus 1 here. So it's a bit confusing. So for the M is that one, and for the R as well. So where is the R? PLLR. So the N is here, the 0 is invalid for the N. And the R is here. So the R is also subtracted 1 because, for example, when we want a factor of 2, we need to write a 1. Okay? So that's why we're subtracting 1. I'm trying to see how we can make this so it doesn't get too confusing, because one in here is kind of clear, but this one, since it's a 1 and a 1, it may get a bit confusing. But well, once you start playing with that, it's maybe going to make more sense. So if we go back to the lesson, we have the steps here. Here's the detailed information in how to configure the PLL. For example, it gives us an example here in how to do 32 megahertz. Okay? Let's go through the steps in how to configure the PLL first. In order to start configuring the PLL, we need to disable the PLL, which is kind of contradicting, but it's actually like that, because if the PLL is already on and running at a certain frequency, we want to disable it first, so we can actually configure it. The PLL is disabled by default when we start the system, But what if you already have it configured to certain speed, and then you wanna, in runtime, you wanna change the speed? You may have to disable it, to reconfigure it. So that happens in this register. I will go through the steps in just a moment, but if this is a PLL on flag in this control register, why don't we just check that? We can check it in here. So let's go to the PLL in the RCC control register. There should be a PLL on here. Yes, bit 24. 1 is PLL on, 0 is PLL off. Set and clear by software to enable the PLL.
All right.
Okay, so if you want to disable it, we need to write a 0 on this one. Okay? But then, we need to wait. Because this is hardware, right? So we are writing things in hardware, but it takes a while. Remember, this is a loop. I showed you how the PLL is a loop. So it's actually a thing that is controlled automatically. So whenever we change something, we need to give it time to set up. So when we are disabling, we need to wait until it's fully stopped. And that happens in this flag, that is in the same register. So there's a PLL ready flag somewhere here, 25. So it is set by hardware to indicate that the PLL is locked and 0 is unlocked. So we're gonna wait until that one is 0. I'll show that in code in just a moment. So this part is just for disabling PLL. Just so we can configure it. Now, we're gonna write the numbers here. The numbers you're gonna come up with. Okay? And we're also going to select the source. In this particular case, we're going to select the HSI. We don't need to enable the HSI because the HSI is already enabled by default. Okay? That's the convenient thing about using the HSI. Every oscillator, every new oscillator that we want to use with this micro needs to be enabled. And when we enable it or disable it, we have to wait for it to be enabled or disabled. So there's a time and a flag that we need to look for. So that whole process is very confusing. That's why the steps are important. But the HSI is already enabled, so we don't have to worry about this. So we write the configuration here. Once all this is configured, then we can enable the PLL again. So now we're gonna go in the PLL on and we're gonna write a 1, and we're gonna wait until the PLL ready is locked. That's what happens here. Okay, at this point we have the PLL already configured, but now we need to enable the PLL and the R outputs, which is the one that we're going to be using. Remember, when we go back to the CubeMX, there's an R output that we're using for the clock system, and all this happens in this register. And lastly, once we have the whole thing configured, only then we can select the PLL as the system clock. If the PLL is not locked, it's not configured properly, if we select it as a system clock, it's not going to do anything. It's going to go back to the HSI. It's going to stay at 16 megahertz. Okay? Okay. So let's try. This is going to be difficult, but not impossible. So what we're going to do is, where is my, I totally lost my, oh, it's right here. Something happened to my Sega. Oh, it's because of this. Okay. We're gonna close all this because I have things that I'm debugging. So I'm gonna go to my demos here. How are we doing with time? We got about 20 minutes left. This is a long session, but unfortunately. So we have a clock demo 1. Oh, so this clock demo, we can work based on this one. Let's just open. So this demo is already, what we're gonna try to do is to configure the clock to 40 megahertz. Since we are dividing the clock output here by 40, we should see 10 megahertz, right? If this is properly configured. And we're gonna start the PLL configuration here. Okay. I'm gonna do it according to the lesson, and let's see if that works. Then I'm gonna check it with my cheat sheet, because this thing can be very confusing. Disable PLL. RCC pointing to control register, and then I'm going to clear that bit, right? So RCC pointing to control register, sorry, underscore control register underscore, which one? PLL on, okay? That disables PLL, okay? I made a mistake there. It's a tilde, not that. Then, wait for PLL to be fully disabled. How do I do that? I need to wait for that PLL ready flag. So I'm going to do RCC pointing to control register and RCC underscore control register underscore PLL ready.
PLL RDY.
Okay. So according to the reference manual, it's unlocked or disabled when this one is 0. So we're gonna wait while it's 1. Okay? Because we want it to become a 0. So we're gonna wait while that is 1. I know, this is hard. I get you, but hang in there. Write the PLL range. So what we need to do here is go to RCC.
PLL configure.
Yeah, PLL.
CFGR.
And we're going to write the numbers here, and we need to do this with an equal sign, okay? Because we want to write, so we're going to write here, write M, N, and R, okay? And all this is going to get ORed with what? RCC underscore
So to do with H.
a PLL configuration, and then we're going to select the HSI. Is it configuration? Yeah. Underscore H. There we go, this one. Oh, PLL source, yeah. Let's look at the PLL configuration register so we are not too confused about this. So the source, the PLL source, is the bit 0, right? And the HSI is, now where is this guy defined? Oh, it's defined here. Okay. All right. So you guys are going to have to come up with these numbers here, okay? Because we want to make this work at 40 megahertz. So I'm just doing the steps so I can push this demo and you guys complete it.
So I assume where we're writing M, N, and R, we're actually going to have to finish that portion of our library before we can do this.
Yeah, but you can go and just finish the part that is belonging to the 40 megahertz by just playing with the numbers here. It's actually not hard.
It's really easy.
Yeah, it is really easy, yeah. So the steps are the difficult ones. That's why I'm giving you the steps. And I should probably say here, step 1, step 2, and this one is step 3, writes PLL range and HSI source. Okay? Okay. Then what is the step 4?
You
Enable PLL again. So that one is an easy one because we just need to do this guy. That one is with an or equals without the tilde. Step number 5, wait until PLL is locked. So now we're going to wait, but it's not the same wait. Now we're going to wait while it's 0 because we want to wait until it becomes a 1 now because it's locked when it becomes a 1. Is that clear or not?
Yes.
Yeah, okay. All right, we can do this. Step 6, enable PLL peripherals and PLL are output.
So RCC pointing to PLL configure.
Yeah. RCC pointing to
Or equal or
PLL configuration register,
RCC underscore
and then
CR.
what do we want to enable here? RCC underscore PLL configuration, and then we want to do what? PLL enable.
PLL enable.
Let me just bring up the reference manual here because I'm getting a bit confused with all these things. The good thing is that we only need to do this once, and then once we have it already, let's move this over. Ah, but I need another screen. Okay, I need to do PLL, peripheral enable, R enable. Okay. PLL CFGR underscore PLL P enable. Ah, come on, EM, okay. And then what is the other one?
The
R enable, right?
REM.
Which one is the least significant bit? Okay, so the R enable is before. There, right?
And then or those together.
Oh my goodness. 4, 5, let me just see if I can have a little bit of indentation here. 4, 3, 2, and 1. Which step are we missing now? 7 and 8. What's step 7? Enable, no, set PLL as system clock. That one is easy. And the enable MCO line is already done here.
Or equals
Okay.
SWPLL.
Enable MCO line. So, and set the PLL as a system clock. We're gonna go to RCC, configuration register, and then we're going to enable the PLL. So RCC underscore SW underscore,
PLL.
sorry, it's CF underscore is FW. Unfortunately, there's no such a thing as PLL. We could define that constant if we want, but it doesn't exist. So we need to go here to the configuration register and see which one is the one that enables the PLL and the SW, which is the least significant part. And is bit 1. No? Is that right?
Bit 2.
Yeah, because we're gonna use the PLL clock. I should probably stay here, switch underscore PLL R clock. That's the one that we're looking for, see? Why is it R? Because remember, the R is the one that matters for the system clock here. So we want to do this guy.
Would be switch 2.
Oh, sorry, I forgot that would be, yeah, bit 1,
Minus.
underscore 1, yeah. Right?
Is bit 0 reserved then?
Well, bit 0 would be, if I do bit 0, then I'll be HC, right? Because remember, the first one here is bit 0. Then the second one here is bit 1. That's what it goes, bit 0, bit 1. And that's why it's underscore 0, underscore 1. And it goes probably up to underscore 2, right?
Yeah.
Yeah, I know. This part is difficult to understand. So 0, 1, and 2. So we want 1. I put this one here. And this is number 7, right?
Yes.
Okay. So, oops. This should do it. You just need to add the M, the N, and the R. So I'm going to push this, and I'm going to let you complete it. Obviously, remember, you cannot push to this repo. You have to make a copy of this. But I don't see you guys until Wednesday, right?
Nice.
So try to get this working. And yeah, and hopefully, and let me see if I have everything correct. You know how can I check this? With my cheat sheets. Oh, you know what? Carl is looking like very worried, but Carl has special access to certain things here. He hasn't even noticed.
Please.
Because if you go to this repo, everything is in here. Where is the clock demo here? Oh my goodness. It looks like we got so much left to cover in this course. Oh, this one was just showing the same thing that we did here. So we need to go to demo 13. Let's see my steps here. Let's see if they're consistent. Oh no, I don't have anything. Oh, this one is just using the library already? But I did a demo with the clock before.
Maybe you go fix them.
Oh no, this one is here, yeah. Okay, so see, first disable PLL. I'm not waiting for PLL to be off. I kind of skip that step, see? That's not quite right.
So it's
It kind of worked, right? Well, because you know why it worked? Why do you think it worked?
Sorry?
Why do you think it worked without waiting for the PLL to be disabled? Why this demo worked?
I assume it happened quickly enough where we didn't need it.
No, the PLL is disabled by default. When you look at the configuration, the control register, let's take a look at that. The reset value is this. So the PLL, where is the PLL get enabled? In PLL on, which bit is that? Control reset, where's the PLL on here? 24, the bit 24 is a 0 by default. The only one is a 5 in here in this area here. So bit 24 is around here. So it's 0. So it's disabled by default, that's why it worked. Okay, then we configure these values. That's exactly what I have here, right? Let's take a look at the two areas, left and right. Or, yeah, right and left. And then, after I have that, I enable the PLL, which is this guy. Then I wait for the PLL to be ready until it's locked. That's what I'm doing here, right? Then I enable the P and the R, which are here. Then I enable the, see this PLL, this mask, I define it somewhere because it doesn't exist. So that's equivalent that I have here. And then I enable the MCO line. Yeah, that's correct. This should work.
Wouldn't that define be just at the top of that main.c file? Interesting. Okay,
No,
never
that's
mind.
probably in my library defined somewhere.
Mm.
Yeah, I think I defined it in my clock library. You guys can define it if you want, if it makes more sense than this _1 that you have here. All right, that's it. Sorry for the long lecture.